All right, guys. So today, Dr. Greenberg will not be available, so I will take care of this lecture for him. Um, so today we're going to go through a bunch of topics. I don't know how much I can cover today, but I'll do my best. So we're going to go through memory address, pointers, and basic Boolean algebra and some C programming basics. So for memory address, there's a be aware of the difference between address and value. So you can consider memory in a computer as a whole bunch chunk of a large chunk of array, all right? And each cell in the array has an address associated with it. So can you guys see the bottom picture? Okay. So on top line, so this is the memory. All those big boxes, small boxes, and those numbers in the red are their addresses. So they are associated with each box. So you can think of it as a mailbox, all right? So you have your own address, let's say 1000 North Sheridan Avenue, that's your address. So which will be your memory address. And what is in there will be your mail, all right? So each cell can store some value, and that's it. And the question for you guys is, does the address should be signed or unsigned integers or numbers? Is it possible for us to see some address like say negative 200? Does that sound reasonable to you guys? Any ideas? Should the address ever be a negative number?
Negative, no.
Why that?
Because it's representing a physical location or a sequence, sort of, and you can't have, like, say you can't have, for example, -2 addresses, so you're not going to have a negative number.
All right, that's a good answer. Yeah, so memory address should always be non-negative numbers. So it should be very surprising for you guys to see some negative address, but it happens sometimes if you don't represent the address correctly. Okay, so next we come with the pointer part. So what is a pointer? So first thing we need to know is the address refers to a particular memory location. For instance, this address 101 refers to this particular cell. 102 refers to this particular cell. It does not cross. So they are correspondingly bounded. All right? So that's why it said the memory address points to its corresponding memory location. All right? A pointer is a variable that contains the address of a variable. So for instance, x and y are just normal variables. The int x was 23, int y was 42. But p here is a pointer. Instead of containing a value, an actual value 104, it contains the address of this memory location. So when we access p, the system will see it's a pointer and it's pointing to 104, so you will get a value of 23 instead of 104. We'll see how it works later. All right. So how do we create a pointer in C? So we have 3 statements here. The first statement, int asterisk p x. The asterisk mark is the pointer sign. It tells the compiler that p is an integer pointer. It points to an int. So what happens is when this statement is executed, this is what the computer gave us, the operating system. It allocates the p, actually should have an asterisk sign here, and an x. They are all integers, but they're not initialized. Or they are initialized with some random or garbage value, as operating system has no responsibility to that. The second statement, when we say x equals 3, means we assign value 3 to int variable x. And here's what we got. We put the number 3 in the corresponding location of x. Next, we use this afferent operator, which gives us the address of the variable. So in this statement, what we have is we assign the address of x to the pointer p, right? So how do we get the value that we pointed to? All we need to do is the asterisk p. So for instance, that is called the reference operator. So in this example, we have p points to value something, and we at the end for this we added the asterisk p, which gives us the value that pointer p points to. Why do we use pointers? Besides of what I have here, like, do you think?
It's a lot faster in some cases, and it's a lot more efficient.
Can you give me an example?
For example, say you have a large array structure that you need to pass between functions.
Yes. Okay.
Instead, like you could have the array declared, for example, in main, and you have a function that calls it, acts on it, but you don't have to copy the entire array as an argument.
Yep. So instead, so that's a very good example. So we use pointer to give us a faster access to some large chunk of memory. So if we have very big complex data structures such as tree, a list, or a graph, which contains like thousands of even millions of nodes and values in it, in C family languages, oh, question?
I was just wondering if this PowerPoint is on the site. So I can follow.
It's not available on Sakai yet, but I will upload them later. And I'm also doing video recording, so you will see the. I'll also upload the video, lecture video later. Okay. So for a large chunk of memory, like data structure, traditionally in C family languages such as C++, C, Java, and C# and Go, they pass, when you call a function with an argument, they pass the value to the function, of the argument to the function. So if we do not have pointer, and we want to have a function that do some operation on a very big like data structure, then what will happen is the system will copy the entire whole big chunk of memory just to give the function, and then let the function operate on it, and then change it back, which is very inefficient. However, with pointer, what we're doing is we just give a pointer that points to part of the data structure, and then from there we can use the function to use memory addresses to and the data structure relationships to access each node or in the list or in the graph and do operations on them. Right? So that is called an indirection. So we do not access large chunk of memory directly. We use pointer to access it indirectly. If you program in Java or C#, how many of you have programmed in Java or C# before? Good. So when you guys pass an array to a function, you're passing a pointer to that function instead of the whole chunk of array. Well, you probably don't see that in the code, but that was how Java and C# was implemented. And the same for those objects. So if you have something like a scanner or a stream reader, and you pass that to a function, you're passing a pointer of that object to that function instead of the whole object, which is a scanner or print writer or stream reader. Okay, so note here I have two different. The asterisk mark operator has two different usages in this example. First one is we use that to declare an array, and second one, not array, sorry, declare the pointer, which tells the compiler that it is a pointer instead of an integer, or it's a pointer to an integer value instead of an integer variable. And then the second one here, we use this asterisk mark, and add with p, formula p, we use that to get the value that pointer p points to. So there's two different uses of that operator. All right, So how do we change the variable that it points to? It's simple. We just use the debriefing operator on the left side of the sign, equal sign. For instance, if I want to change what t points to 5, all I need to do is asterisk mark t equals 5, and that's it. You don't need to know what t points to. All you need to do is you assign 5 to the pointer p, and it will update. The system will update what t points to and change the value. Here, I have a question for you guys. Do we ever need to know what the exact address of x?
Sometimes but not usually.
Why is that?
Because more often it's much more useful to know what value you're being pointed to. But sometimes we need to know to check if, for example, we made a mistake in our code and the address is out of bounds. For example, to check for a negative pointer or a negative pointer.
Very good. That's a very good answer. So usually you don't care what the exact address of x is. In other words, even if you can use this Abraham operator to guess the address and print it out, you do not write that down in the code literally. So for instance, if the address of x is 101, you don't do something like p equals to 101. You don't do that because that's a very bad practice. Most of the time you don't do that. But when you debug, when you have come through a code, your pointer points to some memory allocation that you have no right to access to. You need to know where it exactly points to. So that is when you need to know where the address so that you can fix your program. Any questions so far? Yes.
But can't the addresses change depending on like when you're running it? Because like it could use a different part of the RAM, so like the address changes.
It depends. Like if you okay, so I would say generally no, because if you declare a variable like this int x, the address is fixed at runtime. Unless it's declared on a stack, and the stack like in a function, and then after the function call is done, it's over, and the memory of x will be cleared out.
Okay.
But while in the function, while its x is there, the memory address is fixed. However, there are techniques that you can reallocate memory, but we'll not talk about it today. All right, so more about memory addressing. So there are two ways to address memory. It's called little endian and big endian. What's the difference? So for instance, if we want to store the value 1, 2, 3, 4, 5, 6, 7 in x, big endian will do is it will start from the most significant byte, and from that byte and store them. So big endian will store as 0, 1, 2, 3, 4, 5, and 6, 7, right? So they're all 4-byte integers. So it will be 2 bytes, it will be 2 bytes, 4-byte integers, yes. And little endian will do differently. It will start from the least significant byte and store it towards the most significant byte. So it will start from 6, 3, 6, 7, 4, 5, 2, 3, 0, 1. Doesn't matter. Of course not. Like compiler, like when you write programs, most for us right now, we don't need to care about that because compiler takes care of this. So it doesn't matter if you write your program in a little endian or big endian machine, right? It doesn't really matter. But if you do network programming, little endian machine will read big endian file in reverse order and vice versa. So why is that? So in a little endian machine, because all bytes are set in this order, so when the file is transferred through network to a big endian machine, the big endian machine will start reading from, the beginning part of the file is 6, 7 instead of 0, 1, so it will read it reversely, and it will get weird. no advantages of between one and the other. So it's okay, like it doesn't really matter whether a machine is in big endian or small endian. It's just a convention thing. So if we just pick big endian and stick with it, we'll be fine. And the same as little endian. There was a technical debate over little endian and small like big endian over the years, and there's an interesting story behind why it's called endian. If little was big endian. Anyone knows that? All right. Well, I will leave that for you guys to look up online. All right. So, some fun facts is like network, like servers and many other like network computers are using big endian instead of small endian or little endian, and most of the Intel-based processors are, I should say, all Intel-based processors are little endian. So if you use AMD 64 or other Intel architecture, IA32 will be all little endian. But for your smartphone, recent smartphones, they're based on ARM architecture, so they'll be bi-endian. Means like they can read, if they can read file as little endian or small, big endian. All right, so now we are going to go through some basic Boolean algebra. So how many of you guys have taken discrete math so far? Good. I think you guys know most of this part. So there are, excuse me, there are four basic operators in Boolean algebra: and, or, not, and XOR. For those of you who don't know this, or usually it also means inclusive or. So an XOR means exclusive or. Like I'll give you an example here. So if you buy me a cupcake or chocolate, I'll be happy. Which means you can buy me a cupcake, that's the first option. Or you can buy me a chocolate, the second option. Or you can buy me both. You have three ways to make me happy. But if you don't buy any of them, I'll be unhappy. So that's called inclusive or. Exclusive or says, I'm going to London or I'm going to Paris. Means that I can only go to London or Paris. I cannot go both of them. So that's called exclusive or. You cannot have things that happen at the same time. So why are they important? Sorry. We'll go back to here. So why are they important? Logical operator like and or not, like pretty like natural to us. Like we sometimes we need to write programs to tell whether a condition met or not. For XOR, it is very heavily used in graphics. So for instance, I'm moving my mouse right here, the mouse. Do you know how does the computer tell where the mouse is moving? And how to draw that on the screen? It is using an XOR operation to tell whether it's whether or not. Actually, I should do this. Here, look at this. Right now it's a mouse. Cursor is here. But if I move to the text area, it will change to this I-shaped cursor. So that's what XOR is used actually in the computer. So people use XOR to tell whether or not this mouse is in this blank area as a normal mouse or in some text field that I can edit and change its shape. All right? Okay. And we'll see how XOR works later in the program. All right, so now we are going to go through some basic C programming. I hope you guys have done the homework Ultra on homework 1 so far and have fun with it. So the very basic thing is formatted I/O. So in C, it provides a bunch of I/O, but most of the I/O that we're going to use is formatted I/O. It will be the input and output will be made through the console or the terminal. It's called standard I/O. So in standard I/O, we have the most common function that we use are printf and scanf. Printf in print format. And the argument must be a formatted string. So in this case, we have something like pi equals %mark f, pen equals %d, and my name is %f. So what does this percentage sign mean? That means like if the compiler sees those representations in the string, it will know that it's a formatted I/O, and it will look up the corresponding arguments followed by that. So in this case, %mark f is corresponding to 3.14, which stands for floating point number. Pen equals to %d, and it's corresponding to this number 10, and this %d means decimal number. So the decimal integer. And my name is %s, and followed by this string, which is my name, Yubin, and %s stands for string. So it will plug in whatever followed by this string to its corresponding location. That's called formatted string, formatted output. And similarly, we use the formatted input to get input from users through command line. So, for example, if we want to read an integer from users, what we need to do is scanf %d, which stands for decimal integer, and we have this apprehend I. Remember this one? The address of I, right? So what it does is, it will wait for user's input, and the user type an integer in the command line and hit the enter button. It will get the value from the command line and assign to it. And remember that C pass value argument by value instead by pointer. So if we want to ever change a value to a function, we need to use this address, use the pointer instead of the argument itself. All right. String representation. So there are 3 string representations in C, most commonly used. There are literal strings, for instance. Here, this is a literal string. It's written in the code. It's a constant value. You can also change that. And array of characters. So you can declare an array and say array of 10 characters, and it will assign, say, New York to that array, and it will be a string. Be treated as string in the program. Or you can use a character pointer. We're probably not going to cover it today, but what character pointer does is you declare a pointer and allocate an array, allocate a chunk of memory address, and then let the pointer point to the first character of that huge chunk of memory, and then you assign a string value to it. So all strings in C end with no character. If you have programmed in Java or C# before, it's the same in Java and C#. They all end with this no character, which is /\0. This character is not counted towards the length of the string. So if you want to get the length of the string, you call the library function, and it will return the part that is visible or like that is not no character to you. All right, I have a demo here. I can show you how that works. Okay, so probably let's see. let's do 18. No. It's not better. 14. Standard IO. Alright, here. It looks probably a little bit different from the C program we usually have. So what I have here is I try to get the command line arguments so that I don't have to do another run of I/O to get values from user input. So what I did is, if there are two command line arguments, I'll get the second one, which is actually the active command line argument. The first one will be calling the program, print out the string and the length of that string. So the string will be argv1, and length of the string will be obtained through this library function called stringlen. And if you want to use this function, you need to import this library called string.h. So argv here is a pointer to an array. Right? It's a pointer to an array of characters. And each element in an array actually points to another string or character. So when I have this argv1, it gives me the pointer to the second element of that array. So that's one of the representation of string. How does this program look like when we run it? All right. We'll just run the program from here. If I put my, say something like New York, it'll give me the length of New York has a length of 7. But if I do something like this, whoops. Oh, that's right. Because I say this part will only execute if only 2 command line arguments. But in that case, I have 3 command line arguments, so that's why it don't work. But you get the idea of how to use the format IO for string and get the length of the string, which then has the last character of the string. All right, now we are going to go back to our pointers. So we're going to see how do we operate pointers in C. Remember, this is a very, very error-prone process. Millions of software bugs comes from pointer. And that's why today, software engineering, we prefer to use some high-level languages such as C# and Java or Go instead of using C or C++, unless you're writing some very critical software that demands speed. Because pointer is so hard to deal with and so often to make mistakes. Okay. So what do I have here? Type pointer. Okay, so this is my pointer program. So what I have here is in the first line, I declare an integer I and assign 5 to that. And now I do something different here. I declare an int pointer iptr1, and I assign the value of I to it. All right, I want you to think about what will this do. And then I did something that I showed before. I declare int pointer iptr2, and I assign the address of I to that pointer. And then I'm going to print the value of it. Okay? So this print value is just print out what I is, iptr is, iptr1, and iptr2. And they are all using pointers, I think. What? Should be this. iptr1, iptr2. think there will be some error here. Oh, yeah, I remember now. Well, we'll see how it goes. And after that, I'm trying to get a new value for I, and I update this value of I using the scanf, and then I'm going to print out the value of I, and what I ptr1 points to, and what I ptr2 points to. We'll see how it goes. I'm not very sure after changing that thing. Okay, so. All right, a lot of warnings here. I don't know if it compiles actually. All right, it compiles, but I'm expecting some error here. We'll see how it goes. Okay, seg fault. Very common. If you write programs in C and you have problem with your pointers, you're going to get a segmentation fault. What does it mean? It usually means that you are accessing some memory address that is not allocated to you. So, what does it mean here? Okay, I'll put it here. So when your program runs, remember, I don't remember if we talked this before. So this is the memory you have, the memory that's allocated to your program. You have the instruction here, which is called text. So this is, let's see, 0x 0, 0, 0, 0, and then x, let's see, for instance, like this. So this will be the text, which will be the instruction that is used by your program. And these are the data that is in your continuum program. And we have something called heap, which memory will go up to there. And we have stacks. Memory will scroll from here, from top to bottom. So what happened in my program was, my instruction, so, okay, let's do something else. So there are some other memories. This is part of the memories allocated to other places. So what happened in my program was, instead of accessing to the memory that my program has, what my program does is it's accessing to memory points here. It's not part of my program. So this is my program, the memory that my program uses, and this is others. So if your instruction is trying to access some data that is outside of the memory that allocated to your program, you get a segmentation fault. And that's, the reason behind is clear, right? That you don't want ever that have one program access the other program's memory. Otherwise, things will be messed up. That's how you get computer viruses, right? The computer viruses, which is a special program that can break through some bugs, or break through some protections of the operating system, and access other applications' memory and mess things up. And that's how computer virus works. So in this case, the system tells me I have no access to this memory, and therefore my program will be terminated. Right? So let's see what's the problem here. Here, I declare this pointer. All right, I declare this pointer, so I assign a value to it. But know what that pointer points to. We assign I true, but do we actually make this pointer point to I? Yes or no? The answer is no, because when you declare a pointer here, instead you have this asterisk mark here. What you're doing here is, what happens is, the computer, the system will allocate memory and make that pointer point some random area that we don't know, right? We don't know. And then we assign a value to that pointer, means that the random memory part will have a value of I. Alright? So that's not a big problem. The big problem later. Later. See. So if I remove this one, and this one, and this one, and remove this pointer here. Again, give me all those warnings, but doesn't matter because if you take a look at those warnings, they're just telling me something like it's expecting an int instead of an int pointer. In which case, in this case, really doesn't matter. So what happened here is we print out the value of pointer 1. We print out the value of pointer 2. And now let's say we update the value of I. Let's say we make I equals to 6. However, I pointer 1 is still 5. It's because it's point to some random part instead of the value of I. So when we update the value of I to 6, I equals to 6, I pointer 2 equals to 6, because I pointer 2 actually points to the address of I. But I pointer 1 does not point to that. I pointer 1 only gets the value of I at first instead of the address. So that's why this value is not updated. So what do we what? Okay, now I should do this. Here. Okay. So let's say make it 6. So this is what happened here. Now we correct the pointer I pointer 1 with I pointer 1 points to. We make I pointer 1 points to I. And then when we try to retrieve the value of I pointer 1, we actually get the value of I, which will actually get the value of I pointer 1, which points to I, and which is 6. So when you write the program in C, it's always better to, you should always keep in mind of the machine structure, like a memory structure in your mind, and if you are confused about this, I would suggest you draw a memory diagram and figure out what's going on. So let's verify what happened here. Let's see. Like I said before, what happened here is we assign value of 5 to I pointer 1, which actually make I pointer 1 points to the address that it points to 5. And if you take a look at here, I pointer 2 points to I, and I pointer 2 actually points to the address, and the address of I is here. So that is consistent, which is good. Okay, what do we have next? Type and typecasting. All right, so I don't think I did typecasting, but I did do type. So here's one of the programs I have typed. So there's a keyword in C called typedef, which allows us to define new type that is not in the original C. So what I have here is I define a type of people. And what this does, oh, it's hard to name person, this is one person. And what it does is the people type actually has a type of struct which contains a char, character pointer, and the variable name is name, and an integer value, a. And then what I can do in the main program is I declare variable p type people, and I can change this name, and I can change this a to some value that I get from my app. Does it remind you of something in COS 170? It's like object-oriented programming, right? It's like you define a class people, and there are two instance variables. There are name and a. And this is how you can do some object-oriented programming in C, but with like kind of similar to object-oriented programming, but it's not. It's simply that you define an alias of this more complex data structure. How does it look like when we run the program?
Let's see. Okay. Oops. All right. So we do bin demo type. Oh, okay. Sorry. Let's say what do we have? What do we have here? So we have we want two arguments here. Two extra arguments. The first one is the name, and the second one is the age. So what we can do is Tom, and let's say if this guy's 45 years old. So we print out the value of them, which is we print the value up here, which is name has name and age, and its corresponding name and age, which is Tom and 45. So using type def allow us to
make a lot of new types. You can see this in a lot of C programs. They're doing this a lot. Like they have type that basically in every header file. Like they can make alias so that more complex type can be represented simple like this. All right, what do we have next one? We have logical operations. So the logical operations in C will be similar to Java and C#. We'll have double asterisk for and, double thing for or, and expanded mark for not, and there's no logical operator for or. When does class end?
Okay. All right. I think we probably won't be able to cover bitwise operation today. But I do want to introduce this thing to you if you guys don't know this.
If you want to ever be good at C programming, you need this book. Right? Written by Brian Kernighan and Danny Ritchie, those people who wrote Unix operating systems 40 years ago. So this book, if you want to be very good programming in C, you need this book. It's a very good reference when you have problem in C. Alright?
Okay. All right. I think we could be done today, and I'll see you all on Wednesday.